Alright, let's take a little look at the basic rules for radicals, and do keep in mind that there are some tricky cases, and we're going to, for the moment at least, avoid the tricky cases and just focus on when all of these numbers are positive and nice, and then we'll add in things like negatives and wonder a few things. So let's just remind ourselves of the basic idea that we have an index, a radical symbol, and a radicand, and that we can translate this into an exponential form, which is going to look like b to the 1 over a. Alright, so let's see. What if we had some funny little cases? What if we asked the question of a is the index, and underneath the radical symbol we have b to the a? Well, we can see that this would mean that I have b to the a all raised to the 1 over a, and that's going to be b to the a over a, or just b. So if the index and the radicand have some similar exponents going on, so this radicand includes an exponent of the a level, and the radicand has an index of the a level, then they're going to undo each other nicely. Some inverses here, some reciprocals canceling, lots of ideas going on, and then we'll be just left with b to the 1. Now, there are some funny cases, though. We need to be a little thoughtful about this. In general, if a is even, then we can't consider what's going on here. This would say something like, how about 3 squared and then square rooted? Right, so we put a 2 there. Now I'm going to talk about that for a second. In general, if you see nothing, this is assumed to be 2. So when there's nothing shown on the radical symbol, we assume that this is the same thing as a 2. Alright, so this is saying the square root of a thing squared. Now that should give us the number out, which is 3. But here's the fun case. What if that had been negative 3? And I was squaring it, and I took a square root. Notice I'm not using the 2 now. That would say, really, this is the square root of 9. And the square root of 9 is 3. So whether I started with 3 or negative 3, I ended up with 3, which would suggest that if a is even, that this is going to be the case. It's going to be the absolute value of b. That's kind of a nifty little thing to remember, and kind of a neat way to do absolute values, that we can actually turn an absolute value into the square root of a square. Let's see. So let's look at some other ideas. What if we had perhaps let's make a fresh page here for real proper rules. Alright, so some basic rules then. What if we have a radical that's being multiplied by a radical, and if they have the same index? Let's start with that idea. This is something else. Well, we can see that this is really going to be b to the 1 over a, and this is going to be c to the 1 over a, and from our rules in exponents we know that this was a distributed case of the following thing. This was b times c all to the 1 over a, so we can see that that's just going to be a as the index and b times c as the radicand. So there we are. It looks like if I take two radical symbols with the same index and I multiply, that what I can do is just multiply the actual radicands inside the radical symbol. So that's a nice starting rule for when we multiply. Now what if we were going to divide? Well, let's see what's going to happen there. If we had something like the let's see, the 8th root of b divided by the 8th root of c. Once again, we're going to see that that's really just b to the 1 over a, and that's going to be c to the 1 over a, and therefore from our rules from exponents, we'll have that this is really just a distributed case of b over c to the 1 over a, and therefore that's going to be the 8th root of b over c. So it looks like, again, when we have radical symbols with the same index, that we can divide the actual radicands themselves. And so there's another nice little nifty rule. Now, previously we talked only about having even indices, and right now it'd be wise for us to return to the question of what happens when they are odd. And fortunately, we get off a little bit easier because the odds don't care so much about negatives. So if A is odd, and let's give an example of that, something like the cube root of 8. Now the cube root of a positive number doesn't really have any big change from previously when it was even. If it's even and we have a positive number, it really just turns out to be the same thing. It's what times itself 3 times would give me 8. So I guess I can think of that one. I gave you a nice example. 2 times 2 times 2 is the very thing I would multiply times itself 3 times, so that should be 2. On the other hand, if we had negative 8 in this case, so something like, this would be what times itself 3 times would give me negative 8. And in that case I have 3 multiplications, so if I have a negative in there, that's going to be negative, 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 and that should give me a negative. So indeed, negative 2 times negative 2 times negative 2 is going to be the thing I'm looking for, and that's the third root. And so 1, 2, 3 of those, they get to escape from underneath the radical symbol, and that's going to be negative 2. So unlike the even, which gave us an absolute value, the odd is very happy to have positives and negatives. So it just depends a little bit. And so we can now go back to this simpler idea. If we had negative 2 raised to the 3, and we asked for the third root of that, that's just going to be whatever we have in there, that negative 2. Whereas, maybe I'll put in a little but there, but if that was an even number for an index, say 4, and we had negative 2 to the 4th, then in this case it's going to turn out to be the absolute value of that number negative 2. And in this case that means it's going to be just 2 itself. So there is a big difference between the evens and odds. It's important to remember that.